Have you ever looked up at the night sky and wondered about those tiny specks of light? What about the things we can't see? In the vast darkness between planets, there's a belt of millions of asteroids, remnants from the dawn of our solar system. We're talking about the asteroid belt between Mars and Jupiter. Now, imagine a cosmic billiard game gone wild. What if, by some impossible twist of fate, every single one of those asteroids was knocked out of orbit and set on a collision course with Earth, all at once? It sounds like the plot of a blockbuster movie, right? But what would actually happen? Let's fire up our supercomputer and run a simulation to find out. This isn't about fear, it's about cosmic curiosity. So buckle up, because we're about to witness the most spectacular and hypothetical light show in Earth's history. First, let's get a sense of the scale we're dealing with. The asteroid belt contains millions of objects. Most are small, like pebbles or cars. But there are also giants. The largest, Ceres, is a dwarf planet nearly 600 miles wide. Then there's Vesta, Pallas, and Hygeia, each hundreds of miles in diameter. If you gathered all the asteroids together, their combined mass would be less than our moons, but don't let that fool you. We're talking about an unimaginable number of projectiles hurtling toward us at tens of thousands of miles per hour. This isn't one bullet, it's a cosmic shotgun blast. In our simulation, the journey from the asteroid belt to Earth would take several months. For humanity, this would be the strangest and most terrifying waiting period imaginable. Every observatory on the planet would be pointed at the sky, tracking the incoming swarm. Astronomers and scientists would work around the clock, calculating trajectories and potential impact zones. The sky itself would begin to change. Night after night, the new stars would grow brighter and more numerous. Soon, they'd be visible even during the day, a constant, glittering reminder of what's to come. Global cooperation would reach levels never seen before, the single goal, survival. But could we do anything to stop it? Let's be realistic. Deflecting one or two asteroids is a challenge we're just starting to tackle with missions like NASA Asteroid, but millions. It's simply beyond our current technological capabilities. There are no space lasers or armadas of starships to save the day. The focus would shift from deflection to preservation. Governments would race to fortify underground bunkers, not for everyone, but for a select few tasked with preserving human knowledge, culture, and DNA. The Svalbard Global Seed Vault in Norway would become one of the most important places on Earth, a final hope for restarting agriculture. It would be a frantic scramble to save a sliver of our world, a digital and biological Noah's Ark. Then, Impact Day arrives. The first to enter our atmosphere would be the smallest ones, the dust and pebble-sized asteroids. They would burn up harmlessly, creating a breathtaking, continuous meteor shower across the entire globe. For a few hours, it would be the most beautiful celestial event in history. But this is just the opening act. As the larger asteroids, the size of cars and houses, start to arrive, the real chaos begins. They wouldn't burn up completely, they'd explode in the air with the force of atomic bombs. These airbursts would generate shockwaves that could flatten buildings and shatter windows for miles around. Cities would experience thousands of these explosions, turning the sky into a throbbing, thundering nightmare. The noise would be unimaginable, a constant, deafening roar of explosions and shockwaves that would circle the globe. But the airbursts are nothing compared to the direct hits. Thousands of asteroids, ranging from the size of a football stadium to a small mountain, would start punching through the atmosphere. Each impact would be catastrophic. An impact in the ocean would create a mega tsunami, hundreds, even thousands of feet high, wiping out coastlines across entire continents. An impact on land would vaporize millions of tons of rock, creating a crater miles wide and sending a seismic shockwave through the planet's crust, triggering earthquakes of a magnitude we've never recorded. Our simulation shows the planet's surface becoming a Jackson Pollock painting of craters and fire. But the biggest players haven't even arrived yet. Imagine Ceres, Vesta, and Pallas, the giants of the asteroid belt, making their final approach. Their impacts would be extinction-level events on their own. Each one would release more energy than all of the world's nuclear weapons combined. The impact site would be instantly transformed into a sea of molten rock. The sheer force would crack the Earth's crust, causing volcanic eruptions on a global scale. Dust, ash, and vaporized rock would be blasted high into the stratosphere, an impenetrable shroud wrapping the entire planet. This is the beginning of the impact winter. With the sun completely blocked out, temperatures on the surface would plummet to freezing levels within days, even at the equator. Photosynthesis would stop, plants would wither, and the entire food chain would collapse. Darkness would rule the planet, broken only by the glow of molten lava and the constant lightning from a supercharged atmosphere. It's a world plunged into a deep freeze and perpetual night. Life on the surface would become impossible for anything larger than a microbe. It would be a great reset on a planetary scale. So, is this the end for humanity as we know it? Yes. The surface would be an uninhabitable, frozen wasteland for centuries, maybe even millennia, but Earth itself is incredibly resilient, deep underground, and in the darkest depths of the ocean around hydrothermal vents, life would endure. Extremophile bacteria, organisms that thrive in the most hostile conditions, would barely notice the apocalypse above. They would continue their quiet existence, waiting for the world to heal. And it would heal. Over thousands of years, the dust would settle. The volcanoes would quiet down. The sun's light would once again reach the surface, warming the planet and melting the ice. From those pockets of survivors, life would begin its slow, patient journey to reclaim the planet. Evolution would get a fresh start. New species would emerge, adapting to the transformed world. It's a process that has happened before in Earth's history, like after the asteroid that wiped out the dinosaurs 66 million years ago. That event paved the way for mammals, and eventually us. An event like this, while wiping the slate clean, would ultimately create a new world with new possibilities for life. It's a powerful reminder that while our own civilization is fragile, life itself is incredibly tenacious. The planet would go on. What can we take away from this incredible, hypothetical scenario? It's not a prophecy of doom, but a profound thought experiment. It highlights the incredible forces at play in our universe and our own precious place within it. It also underscores the importance of science and exploration. The more we understand the cosmos, the better prepared we are to protect our home. Programs that track near-Earth asteroids are our planetary immune system, and they are more important than ever. So next time you look at the stars, remember the incredible cosmic ballet happening all around us. We are part of something vast and amazing. Thank you so much for joining us on this wild cosmic journey. If you enjoyed this simulation and want to explore more mind-bending what-if scenarios, make sure to hit that like button and subscribe to the channel. Let us know in the comments what cosmic question you want us to tackle next. Stay curious, and we'll see you in the next video.